Hi everyone, we're going to do another problem on weight percent, which again is related to our first course goal, especially because it is a concentration unit. Now, can you imagine having a stock solution that contained 50 weight percent sodium hydroxide, and the density of that solution was 1.53 grams per milliliter. Remember, that's grams of solution, not sodium hydroxide, grams of solution for every 1 milliliter. And let's say that the formula weight of that sodium hydroxide is 40.00 grams per mole. So we've got this stock solution, and we want to know how many grams of this solution should be transferred or diluted to a total volume of 1 liter. So this is a 1 liter vol flask. And if I dilute to the mark with deionized water, how many grams of solution do I add to this flask such that the final concentration is 0.10 molar sodium hydroxide? So there are a lot of different ways that you could solve this problem. Some of you may want to approach this problem as a dilution problem, and you may want to use the dilution equation where C1V1 equals C2V2, and you might want to call this C1, and you might want to say, well, what is V1? And then you might want to call this C2 and this V2. I've seen students do it that way, and that's fine, but it is a little bit more work. I chose to do it differently. I chose to think about, well, if the concentration is 0.1 molar sodium hydroxide and I know the volume, I chose to ask myself, well, how many moles need to be transferred, or how many moles need to be in that volumetric flask, and where are all those moles coming from? Well, they're going to be coming from our stock solution. So if I can figure out how many moles of sodium hydroxide need to be in here, I convert that into grams of sodium hydroxide. And then from there, I can figure out how many grams of solution I need. So a lot of you are going to be able to figure out how many moles of sodium hydroxide are needed in this solution without even doing any work, but I'm going to write it out. So the desired concentration here is 0.1 moles of sodium hydroxide for every liter of solution, right? That's the definition of molarity. And we want 1 liter of solution. So really, the moles of sodium hydroxide that we want in this vol flask are simply 0.1 moles. So how many grams of solution do we have to add then? Well, I might say that for every 1 mole of sodium hydroxide, there are 40 grams of sodium hydroxide. So the next thing we need is, if we know the grams of solution, the grams of sodium hydroxide, how many grams of solution do we need? And by solution, I mean this stock solution here. Well, this is where we would use the definition of weight percent, right? We know that for every 50 grams of sodium hydroxide, there would be 100 grams of solution, and I think that does it. I think that does it. Now, before we solve the problem, let's look at our sig figs. We have 2 sig figs here. 3 sig figs here, 4 sig figs here in the formula weight, and in the weight percent they were kind of ambiguous. So I'm just going to assume 2 sig figs here. So let me do the arithmetic on my calculator, and again I hope you do the same. 0.1 times 1 is just 0.1 times 40 times 100 divided by 50. Oh, I'm getting exactly 8, so I have to have 2 sig figs and call it 8.0 grams of solution. That's the final answer. And notice the way that I did the problem, I didn't even use the density. However, if you were to do the problem using this equation, you would have needed density, and that's why it was given to you. So I hope you enjoyed this example on using weight percent in a dilution type problem, even though I didn't actually use the dilution equation. So that's it. Thanks for listening and hope you enjoyed the video.